Hello, and welcome to a continuation of the topic of area under a curve. So, as I promised earlier, this is going to handle two more examples of a topic that I deem to be of great importance, especially given the fact that yesterday's tutorials were built on very easy examples, and we've been progressing as we do more examples into harder and uh, uh, far much more deeper problems that actually involves area under a curve. So in today's example, I'm going to handle a situation where we are having two areas, which we are having two segments of area enclosed by a curve, the x-axis and the line x1 and x10 that you're seeing here. So before you solve this problem, it's all these problems that involves areas under a curve. It's always important that you know the roots of these curves, because then they give you perspective into the limits, okay, whether they are out of bound or they're within bound. So usually if the limits are within bound, then it simply means that you're dealing with one segmented area. If it's out of bound, then it means that you're dealing with two segmented areas. So the first thing you would want to do is find areas of intersection with the x-axis of this curve here, y, all right, given to be equal to x squared minus 10x plus 10. And be given that this is not a quadratic equation class, I'm just going to go ahead and state the roots. But in your particular case, I hope you, as you are there, I hope you know how to find the roots of a quadratic equation. This is a quadratic equation right here. Okay, so basically the roots of this quadratic equation for x1, after you solve it, and when you solve it, you'll find that x1 will be equal to 1 and x2 will be equal to 9. So basically the range of x is between 1 and 9. So anything outside of 1 and 9 is outside of the range. Okay, so when you look at the values of x that we've been given, we're being told the lines are x equals to 4. So x equals to 4 is between 1 and 9, so that is within range. And we are being told it's x equals to 4 and x equals to 10. However, when you look at x equals to 10, it's out of range, okay? Because when you look at the roots are supposed to what we call area of bound should be actually between 1 and 9. So given the fact that x10 is not between 1 and 9, it simply means that it is out of bound. So it is basically what this insinuates is that we're going to have two segments that actually is enclosed by this curve x-axis and these two lines x4 and x10. Let me show you in a graphical example, then you'll be able to relate to what I'm saying. Okay, so I want you to look at this particular curve, and I want you to watch the two segments that I was talking about. All right, so I said that the roots were actually 1 and 9, and I want you to look at this particular curve here. So the curve we are having forming the parabola shape there is given by the equation y x squared minus 10x plus 4. Okay, and you can see it is enclosed by the x-axis right here. Okay, and the line x equals to 4 and x equals to 10 on the side right here. Okay, so I told you that you should first of all think of the roots when you're thinking of equations under the curve. So the roots I gave to be 1 and 9. All right, so you can see here that is approximately from the origin, that is approximately 1. And so the areas of intersection are 1 and 9 right here. You can see 9 here. That is another area of intersection. Those are the two roots. Okay, however, we noticed that the areas of bound given from the equation were x equals to 4 and x equals to 10. And I told you that x equals to 10 was out of bound. Okay, so it was not within 1 and 9, it was out of bound, as in it has gone beyond the roots. So you can see that from x equals to 9 we have x equals to 10, which is beyond the root. And of course, now that presents us with a unique problem where we're actually having two segments, where we have the first segment of the shaded region and the second segment of the shaded region. So we're supposed to find the area of this shaded region below the x-axis and this shaded region above the x-axis. Okay. So that is the nature of our problem, and that is what we are in for. So for the first, for the region below the x-axis, we are going to integrate from the with the limits 4 and 9. Okay, so 4 and 9 is going to be area given by the shaded region below the x-axis. Then for the region above the x-axis, we are going to integrate definitely, of course, with the bounds, with the limits 9 and 10. Okay, then we'll add those two to give us the total area of the shaded region, as you can see there. Now let us go ahead and handle this example as we should. Awesome. So we are basically going to solve this by finding the definite integration from 4 to 9. Okay, remember 4 to 9 was within the bounded region that is below the x-axis. So from 4 to 9 of x squared minus 10x plus 9 with respect to x. So we're going to find that area, okay? And then we're going to add it to the region. So the total area will then be, for us to find the total area, we're going to add it for the area from the limit of 9 to 10. That was the area just slightly above the x-axis, okay? 9 to 10 there. Of course, we are integrating the curve, and that is going to be x squared minus 10x, okay, plus 9 with respect to x. And so we're going to integrate for these two with these limits and then add them all together. So this here, when integrated, x squared will be x cubed, okay? Then of course we divide by the power of the variable there. Of course, that is going to be 3. Okay, then minus. Okay, so in 10, when you integrate negative 10x, okay, you're going to have the power of x, first of all, raised to 2, as it's 1 plus 1, okay, so it'll be raised to 2. So we'll divide that by negative 10. So negative 10 divided by 2 will give us 5. So this here will give us 5 x raised to 2. So it's going to be negative 5x raised to 2, okay, plus, of course, 9. We have x there raised to 0, so it's going to be 9x. 9x, of course, and the limits are 4 to 9. 4 to 9. All right. So that is going to be for the first integral part. Then for the second integral part, we are going to add, of course, that's going to be plus, okay? The same thing. Remember, the same function we're integrating here is the same function we're integrating here. So we don't have to like go through all that again. So it's going to be x squared or divide by 3 minus 5x squared, okay, plus 9x. Of course, the only thing that changes here are the limits. So the limit that changes here, we're going to have 9. So it's running from 9 to 10. That is for the area above the x-axis, from 9 to 10 there. Okay, so I want us to deal with the left-hand side first, then of course the second, and we're going to add them together to find the total area of the enclosed region of the curve, okay, of the enclosed region that we saw in the diagram earlier on. So basically this therefore means that for us to find the total area, we are going to have the difference of the upper and the lower limit from this particular equation. That's going to be 9 cubed. Okay, so wherever we have x, we're going to have 9. So it's going to be 9 cubed divided by 3 minus 5 into 9. 9 squared minus 5 into 9 squared, okay, plus 9 into 9. All right, so that is it for that. Of course, let me have it there. For the that is it for the upper limit. Then of course, for us to find the area, remember we're supposed to subtract the lower limit, minus. So our lower limit here is going to be wherever we are having x, we're going to have 4. So that's going to be 4 cubed all over 3 minus 5 into 4 squared, okay, plus 9 into 4. Okay, so by getting the difference of these two, we will find the area of the shaded region below the x-axis. All right, so that is, these two will give us that. Okay, so this is going to give us the area below the shaded region below the x-axis. But remember, we are supposed to find that and then the area above. So after we've done this, we'll also do the same for the one above, that is, then add them. So it's going to be plus. Okay, so we begin with the upper, we begin with the upper limit there. So it's going to be, wherever we have x, we put 10. So it's going to be 10 cubed all over 3, okay, minus 5 into 10 squared, okay, plus 9 into 10. All right, so all that minus, so the difference of the upper and the lower limit. So the lower limit is 9, so it's going to be 9 cubed all over 3 minus 5 into 9 squared, okay, plus 9 into 9, of course, and then we find the difference of all of that. So we are going to then basically just simplify all of this and find the whole area or the shaded region. All right, so at this particular point, if you have a calculator, I advise that you use your calculator. All right, I advise that you use your calculator. So for the first bracket, we are having 9 cubed, okay, all over 3, okay, minus 5 into 9 squared into 9 squared, plus 9 times 9. And you'll notice that this here will give you this first equation here will give you let me make sure. Yes, so the first bracket here will give you negative, okay, will give you negative 81, negative 81. That's for the first bracket. And so it's supposed to be negative 81 minus whatever we'll have in the second bracket. So in the second bracket, we are having 4 cubed, okay, so it's 4 cubed divided by 3 minus 5 into 4 squared plus 9 into 4 plus 9 into 4. And notice that this will give you negative, so it's going to be minus negative 68 all over 3. 68 all over 3. So basically this value here is the value for the second bracket. So for the first bracket, we're getting negative 81 minus, so in the second bracket, we're getting negative 68 all over 3. Okay, so that's it for the area below the x-axis. Now for the area above the x-axis, we are having what we are seeing there. So why don't we solve for this bracket here particularly? Okay, using your calculator, it's going to be 10 cubed. You can do it together, all over 3 minus 5, okay, into 10 squared. Okay, minus 5 into 10 squared plus 9 into 10, plus 9 into 10. And notice that you are going to get negative 230 all over 3. Negative 230 all over 3 minus, okay? So we are going to deal with whatever we have in the second bracket. So minus, so what do we have here? So whatever we have in the second bracket, remember this is the same as what we had here. So we expect that the same answer we got here is what we'll get here. And so when you take 9 cubed, okay, all over 3 minus 5 into 5 into 9, oh sorry, minus 5 into 9 squared plus 9 times 9, you will get negative 81. So that's all going to give you negative 81. All right. So it's going to be negative 230 all over 3 for this particular bracket, minus negative 81 for this particular bracket. All right. So when you do the math, let us first of all simplify whatever we have in this bracket right here. So when you have negative 81 minus negative 68 over 3, okay, you will get in a moment. Let me give the answer as a mixed fraction. You'll get negative 58 and a third. All right, you'll get negative 58 and a third. And given that this here is the area of an enclosed region, we are going to take its absolute value. Negative simply means that it's an area below the x-axis. So we will then have this as an absolute value. So it's going to be the absolute value of negative 58 and a third. That's going to be 58 and a third, basically. Okay, plus. Okay, whatever, same to here, whatever, but basically we are going to get a positive answer because it's area above the x-axis. So when you take negative 230 divided by 3, all over 3, I mean, minus negative 81, notice you are going to get, and I'm going to give the answer is a mixed fraction, you're going to get 4 and a third. 4 and a third. All right, 4 and a third. So when you add these two, so when you add 58 and a third, all right, and 4 and a third, then you'll be able to find the total area of the shaded region, and that's going to give, yes, so that's basically going to give you, that's basically like taking 58 plus 4, which will give you 62, all right, and then a third plus a third, which will give you 2 thirds. Okay, so this here is going to be the area of the curved region, and of course its area, so it's going to be 62 and 2/3 square units. All right, so that's it for this particular problem. I believe that it was easy, and if you have any question, maybe you didn't understand any part, just write it, drop it in the comment section. All right, drop it in the comment section, and maybe we'll get back to you. So why don't we go ahead and handle the last example under this particular subtopic? All right, so for the second example, so we're supposed to find the area enclosed by the curve y equals to 9x minus x squared, all right, and the line y equals to x. So before I solve this particular problem, I want to make certain things clear. I want to point out certain hints that we are going to use to solve this particular problem. So unlike the other problems that we've handled, this problem has no boundary, upper and lower bound limits defined. Okay, so basically we don't have any statement indicating the values of x. Okay, however, we are having two values of y. So we are having y describing the curve and y describing a line. All right, so to solve this particular problem, the first thing we want to do is to find the limit. Okay, so that's the first thing we want to do. Yes, you want to find the limit of this particular area that has been enclosed by these two curves that are described using variable y. Okay, so for us to find the limit, we have y being equal to 9x. We have y being equal to 9x minus x squared, and I'm going to call that equation 1. Then we are also having y at the same time being equal to x. I'm going to call it equation 2. So basically what this means is that equation 1 and equation 2 are equal. Okay, equation 1 and equation 2 are equal. Therefore, if I take equation 1 minus equation 2, because they are both y, I should get what? I should get 0. Okay, so that's going to give us a very peculiar scenario where if I take 9x, okay, minus x squared, okay, for equation 1 minus, of course, x, I'm supposed to get 0 because all of them are y. So y minus y will give us 0, okay? All of them should give us, basically the difference of that should give us 0. And so I want you to note that when we open our brackets, we are going to have 9x, okay, minus x, okay, when you collect your like terms, minus x squared being equal to 0. And so 9x minus x is basically going to be 8x minus x squared equals to 0. I hope you are able to follow and that you're following, all right? So notice here that x is a common factor. So when we factorize x out, we're going to have 8 minus x, of course, being equal to 0. That means that we have two values of x. It's either the x that is outside the bracket that is equal to 0, because any number multiplied by 0 will give us 0, or whatever we have in the bracket will be 8 minus whatever, 8 minus 8 giving us 0, so that whatever we have outside the bracket times 0 will be 0. So basically, x1 will be equal to 0, and x2 will be given by, of course, that is 8 minus x equals, which is, let me just write it, 8 minus x equals to 0. So basically, x2 in this particular case suggests that will be equal to, when you take 8 on the other end, of course, when you make 8 x the subject here, basically you get that a2 is actually equal to 8. All right, so those are going to be our limits, okay? Our limits, therefore, are going to be described, okay, by 0 and 8. So 0 is going to be our lower limit, and 8 is going to be our upper limit from this particular problem. So that's the first thing, finding our limits, okay, which we now have, our upper limit and our lower limit. Now, the second thing that we're going to do to solve this, because we are not having a situation where the x-axis is actually involved here, for us to find the area of this enclosed region by y being equal to 9x minus x and y being equal to y being equal to x, we're basically going to find the integration, the definite integration of both. We're going to get the difference of the definite integration of both of the lines, both of the curves. So let me just have a line here. And so the area will be given by, the area of the enclosed region will be given by the definite integration of of this line here. Let's have it, of course, we know what it is. Let's have it here as 9x minus x squared with respect to x. Of course, the limits are from 0 to 8, okay? That is minus the definite integration of this here, this second equation, because all of them are given by y. So it's going to be 0 and 8. So basically, the definite integration of x with respect to x. All right. So what this basically means is that we are going to have, we are going to have, when you integrate 9x, 9x, of course, you're going to have 9x squared all over 2, okay? So that's going to be 1 plus 1, 2, and then, you divide the whole term by 2, so that's 9x squared all over 2, okay? Minus, okay, x cubed all over 3. I hope that by now integration is not a problem. We're just adding 1 to the index, then dividing the whole variable by the sum of it. Okay, the sum of the index. Okay, so so that's going to be the limit 0 to 8 minus. So when you take x and integrate x here, it's going to be x squared all over what? All over 2. Of course, we are still having the integral process for the limits from 0 to 8 there. All right, from 0 to 8. So notice okay, that this here is going to give us. So we're going to take the upper minus the lower. So anywhere we have, okay, the upper minus the lower limit. So anywhere we have x, we're going to have 8. So that's going to be 9 into 8 squared all over 2 minus 8 cubed all over 3. Okay, all of that minus 9 into, so for the lower limit, anywhere we have x, we're gonna put 0. 9 into 0. Let's actually have it in bracket. 9 into 0 0 squared, all over 2, minus 0 cubed all over 3. All right. So we are done with that. Okay, we are done with that particular end. So minus. Okay, so for the upper limit, we're going to have 8 squared all over 2. Okay, all right. So that's it for the upper limit, just that. And then for the lower limit, minus 0 squared all over 2. Yes, all over 2 right there. So I want you to note that any number multiplied by 0 is going to be 0. So basically, this whole term here is going to come to 0. All right, that is this second bracket. All of it will be equal to 0. So this is what you're going to constantly, focus on for this particular problem. So if you have your calculator, you can use it. So that is 9 into 8 squared all over 2. Okay, minus 8 cubed. Okay, all over 3. And so you get this will be equal to 352. 352 all over 3. Okay, of course, 352 over 3 minus 0 is just 352. Okay, all right, so that's it for that. And then minus, of course, this here also will go to 0. All right, it's 0 divided by a number is always going to be 0. So it's 0 squared divided by 2 is going to be 2. So, okay, so we're going to be left there by 8 squared divided by 2, of course, and that is 32. So when you do the math here, so 352 divided by 3 minus 32. Notice that, let me have it as a mixed fraction. You're going to get 85 and a third. 85 and a third square units. So the area of the enclosed region by the curve y1 and y2 will be 85 and a third square units. So that's it for this particular class. We're done with areas under curves by use of definite integration. So if you have any question, drop it in the comment section, and we'll get back to you as soon as we can. Otherwise, have a lovely day.